Welcome to my YouTube channel at the rate Code with Anvesha. Yeah, thanks for joining me in my journey from backend to AI developer. Previously, we have seen LLMs. We talked about single agent, we talked about RAG, vector database, embeddings, and so on. What next? Yes, we are here to discuss multi-agents. What is multi-agent? How does it work? Why do I need to know it? Yes, to answer all of these questions for you, here we are with the next episode. Let's get started. What's a multi-agent system? So you can understand it as like an AI agent which has specific role, and all the agents are having their own specific role, but they are working together to solve a complex problem. For example, in a software development environment, we have a backend engineer, front-end engineer, a QA, a product engineer, product developer. So all of them are specialized in their areas, and everybody is trying to solve one complex problem. That's why since everybody is specialized and working on a particular role, the output is expected to be a better one. So that's why we are entering into this multi-agent system. It will have a lot of other complexities like how the agents interact, maybe like whether they are interacting sequentially to the LLM model, or they are interacting like parallel wise, or a hybrid model. That we'll discuss later on. But yeah, in order to get this started, what I have done is we are keeping the same career agent, just modified it a bit so that I can explain how we are working on the multi-agents. So what you can do to get started is just get the pull from the GitHub repo that I have already shared, and yes, we'll start from there. So without much ado, let's get started. So before running into the code base, let's understand the flow of the code base. So first, we have a user which gives the prompts, the orchestrator layer, which helps us understand which agent will work and where. Then we have multiple agents. Multiple agents, for now we have different kinds of agents, as you can see: user input, resume agent, skill agent, roadmap agent, salary agent. So these are the agents that we are putting as of now. The LLM and the combined report. So that's how the flow of the code will be. Currently, I discussed that there can be different ways of interaction of the agents: agent 1, then agent 2, and then agent 3, independent, right? This can be a sequential agent. Then agent 1's output goes to the agent 2, and then agent 2's output goes to the agent 3. This is called a parallel multi-agent group. Moving to the code base, yes, I told you to get the pull. Earlier we have worked on career agent. In the career agent, we discussed, we had a system prompt, we had memory, we have messages, and then we were feeding that into the Ollama model. We were getting the response, and that was acting as an AI career coach. It was just defining us, right, based on the system prompt. We asked it to behave like a honest senior tech lead and guide us on these career growth and so on. And we were expecting the response from the Ollama model based on that prompt. This was our very first base. Then we moved to the career agent V2, where we brought in vector database, NumPy for mathematical calculations, sentence transformer, and PDF plumber. So we were actually incorporating our resume, and after incorporating the resume, we were asking it to behave like a different mentor. Like it was sometimes behaving like a AI mentor, and then suggesting us based on our resume put current situation, skill gap, and roadmap, and so on. It can switch back to the backend mentor, and then again guide us on system design and distributed systems and backend systems and so on. Or it can have an interview mode, right? So we were loading the resume, and then we were having different kinds of modes, and based on that modes, it was able to answer us. We were using RAG in it to load the knowledge. We were chunking it, we were embedding it, and then we were using vector database, right? and then we were retrieving the context on it. We had definitely a context orchestrator layer, which was basically telling us how to move ahead. It had a role, it had a content, and yeah, we were using RAG inside it, and we were getting that career agent. But what was the problem with it? That I had to move to this multi-agent mode. So it was one agent which was doing everything for us, right? It was guiding us, it was suggesting the loopholes, it was suggesting the strategy and the roadmap, preparation roadmap, and mock design, system design interviews, and based on our resume, it was suggesting us the problem statements where we can work on. So since it was restricted to one LLM model, one agent, it was not that much accurate. So in order to get that more accurate, I have built a multi-agent system, which is career agent v3.py. We are importing Ollama, we are having that vector database, we are having NumPy, sentence transformers, and PDF plumber for importing. Okay, we have the global context here. First, we'll load the knowledge. Loading the knowledge, like once the PDF is imported, right, and then we are chunking it and then embedding it into like 365 dimensions, and then putting it in a vector database and so on. So after those resume load is done, these I have kept the same as we were doing career agent v2. Just what we have added is multi-agent layer, where you'll find the differences in this base agent class, right. So first I tried it with a single sequential agent model. When I say sequential agent model, yes, we are talking it this sequential one, agent 1, agent 2, agent 3, and independent. Like every agent is working independently. That means every time we are giving a call to LLM model, which is like little costly, because agent 1 will work and then it will give a call to the LLM model, then agent 2 will also work independently, will give a separate call to the LLM model. So that's why the tokens cost increased. So that is one of the problems that I found with the sequential agent model, but I'll show you how it's working. It based on write different problem statements that we can use single sequential agent or sequential multi-agent. So just for that purpose, so we have a base agent class here, we have a run module, which is actually acting as like a context model for us. We are putting self and user input here. We are using this retrieve context, right. We are putting the messages, role, system, right, and after getting this messages, right, we are expecting the response from the Ollama.chat after putting this model and the messages. So we have specialized agents. For the specialized agents, we are calling this base agent, right, the class that I showed you previously. And we have resume agent, which has a prompt like your resume agent analysis, a resume agent analyze the strength and weakness in the resume and return bullet points. Then we have a skill gap agent, we have a roadmap agent, and then we have a salary agent, and then an interview agent, right. So we have different agents for it. Now the orchestrator, I remember like in the model I've showed you the orchestrator. Yeah. So orchestrator basically defines that how the multiple agents will interact. Like they will, it's actually managing these multiple agents before it gives a call through the LLM model. So we are having resume output, resume agent dot run. Like if you see every time it is giving a single call to the LLM. Skill gap agent, the roadmap agent, the salary agent, the interview agent, and so on. So that's how we were defining it, right, to get the final response. We are iterating it and asking every time the user input with you, unless an exit or a exit is written. So that's how we have written it. I have just tried with some basic examples like to see how the model is performing. You can start it by running that Python 3 career agent v3.py, and then you'll see that it will start running the resume analysis, the skill gap analysis, and then generating the roadmap, right, building the salary strategy, preparing the interview plan, and every time it will call those specialized agents for it. So what is happening is that we are getting better responses, right. But yeah, as I discussed, the loophole of the sequential agent is that it is giving every time a call to the LLM, which is costly, and latency is also increased. So I thought of changing it to a parallel one, When I say a parallel one, I mean this. Agent 1 is giving the output, the output is going to the agent 2 is giving the output, and that is going to the agent 3, right? So every agent has the context of the previous agent, right? That is the parallel agent that I am talking about. So this is the context behind it. So it will retrieve the knowledge, right? The RAG that we discussed, it is loading the resume for us. I have loaded it, I have chunked it, I have then embedded it and then call this vector database, right? And then retrieve the context for it. The messages that we are building, the messages, role and the content behind it. So the user resume, resume context and the relevant knowledge, which is knowledge to it. So we are building the messages, we are building it in that MCP style context, right? And then we are adding the previous agent output if available. So that is why there is a difference here that is seen in the run model. Earlier it didn't have the context of the previous one, but since I am running it in the parallel way, it will have the context of the previous one. So if shared context messages.append role system context previous analysis from the other agents, right? And then and so on, it will add the user input and then append it, and then finally it will call the LLM, right? After the multi agents have worked, it will finally call the LLM, and then the specialized agents as earlier. The other difference that you will find it in the orchestrator, how the orchestrator is written. So earlier the orchestrator was simply we were running it, calling those and running it. Now it will have the context of the previous one before running it. That's the difference that you'll find it. Yeah, after running it, I found that the latency is reduced. Now it is responding in a more faster way. So yes, that was about the multi-agent system. Do let me know how did you like it, were you able to perform it and then see the difference for yourself, and were you able to understand the multi-agent system thoroughly. Do let me know what else you were expecting in this, the topics that I have covered, how well you were able to understand it, and if you really liked it, don't forget to give a like and subscribe to my channel for more upcoming videos on it. Thank you so much.